Another class in the Java class library that is very helpful is the math class. The math class provides all sorts of mathematical functions like finding the absolute value of a number, taking the square root of a number, raising a number to an exponent. There's all sorts of trigonometry functions. There are constants in the math class like pi and e. So any sort of mathematical function you might want, you should take a look at the math class to see if it's there. Now the methods of the math class are what are called static methods. These are also referred to as class methods. We're going to talk about these a little bit later on, but for now, all you need to know is that in order to invoke these methods, you do something a little bit different. So you don't actually create objects like we've been talking about this entire lecture series, but instead you just invoke the methods through the name of the class. So here, for example, we say capital M math, that's the name of the class, dot abs for the absolute value. Capital M math dot square root. So this is not an object, it's the name of the class. And that's how in general you invoke static methods. Again, we're going to talk at a later date a little bit more about what static means. But for now, just know that in using a static method, the way you invoke it is different. You don't invoke it on an object. So we're never actually creating an object of the math class. We never say math M gets a new math. It's just that it's not how the class is set up. We don't do that. So instead, we invoke the static method through the name of the class. So name of the class, dot operator, name of the method, and then the parameters. Okay. Typically, static methods are used for methods that are more like functions rather than behaviors of an object. So finding the absolute value of a number is really like an input-output type thing. It doesn't rely on an object. And that's kind of a rule of thumb for most static methods. But again, don't worry too much about understanding static right now. For now, just focus on when and how you'll use it. And in particular, when you're using the math class, you'll invoke the static methods. The math class is in the java.lang package. Remember, that's the package that is automatically imported, so we can just use it whenever we want, and we don't need to import it. So let's write a little method with the math class. So we're going to write code to calculate the following based on a user's input. So we're going to calculate the area of a circle and the distance between 2 points. So I am going to create a new class. I'm going to call it geometry tester, something like that. And what I want to do is I want to read in the radius of the circle from the user, and then I'm going to calculate the area. So I'm going to start out by telling the user to give me the radius. And I'm going to, just for simplicity's sake, assume we're only going to allow whole numbers and not decimals. So then I'm going to create my scanner object. Scanner scan gets a new scanner. And I'm going to read the input of the user into an integer called radius. I'm going to store their input variable called radius. And I will use the nextInt method to do that. Now, previously we've only used the nextLine method. Remember, nextLine reads until whatever the user is typing until they click enter, and then returns a string. NextInt reads in and returns an integer that the user types. Now, this does rely on the user to actually type an integer. If the user types something else, the whole thing crashes, but we're going to not worry about that right now. Of course, I need to import my scanner class, or I could have imported the whole util package. So what is our area going to be? Well, remember our area from this slide here is pi r squared. So I'm going to use the math class to help me with that. And the circumference, oops, sorry, we're doing the area, is math.pi times math.the power of radius to the second. Of course, I could also just write times radius times radius. Okay, so here's some examples of using the math class. We can also find the circumference, which is 2 pi r. And then we'll tell the user. Okay, so there's an example of using the math class, and now let's use it again to find the distance between 2 points. So what we can do is we can again ask the user, enter the x1 coordinate, and read that in. And then I'm just going to copy this and modify it for reading in the y1, storing it in y1, and the x2, storing it in x2, and the y2, storing it in y2. So now we've got our 4 integer coordinates. The distance is going to be the square root, so math.square root of, let's look at our formula. Well, we want to square the difference between the x coordinates, so perhaps we can have some other variables in here to keep this a little bit simpler. So our first term is going to be math.pow x2 minus x1 to the second power. And our second term is going to be math.pow y2 minus y1 to the second power. And then our distance is going to be the square root of those two things added together. So the square root of the first term plus the second term. Missing a parentheses there. And then we can tell the user. Okay, so here are some examples again of using the math class. If you want to see some other things in the math class, you can Google the Math API, Java Math API. It'll be the first link that comes up. And you can see some of the other methods. Here's all the trigonometric methods, and there are your two constants, e and pi, and you can see lots of other methods that Java gives us. There is also a random method in the math class. It does something similar in terms of returning a decimal value. You're welcome to use this as well. I find the random class easier to use, and it gives you so many more options. But if you just want a quick random double between 0 and 1, the same range as the next double method returns in the random class, then you can use the random method of the math class. If you're going to use that, you would invoke it as capital M math.random, because math is a static, random is a static method in the math class, just like all the other methods in this class. So one other thing, collection of classes we're going to talk about that's in the java.lang package are the wrapper classes. Now, the reason we use wrapper classes isn't going to be clear for a little bit until we start working with graphical user interfaces, but I want to introduce them now because they're part of these classes, this collection of classes that we use so often. A wrapper class is a class or object version of a primitive. So here are 8 primitive types, and there is basically one wrapper class associated with each primitive type. The wrapper class is essentially the same name as the primitive type, but it's capital because it's a class, and it's the full word in terms of, for the char is actually called character. So an int is called integer. Okay, so there is one class associated with each primitive type. And basically the purpose of a wrapper class is to just represent a primitive value as an object. So sometimes you'll need an object. Again, this will become clear when we are dealing with collections a little bit later on and when we're dealing with graphical user interfaces. Sometimes you're required to have an object variable, not a primitive variable. But really the data you have is a primitive. It's just a number or it's a character. But if you need it to be an object, what you can do is you can use the wrapper class to create it as an object. So for example, if you had the number 40, but you need it to be an object, you can say capital I integer age gets a new integer 40. So age is now an object. Its type is integer, but the value of age is just a number. That's all an integer stores. Similarly, you could have a Boolean with the value of true or false, but this is an object instead of a primitive. You could also have a character. This is again an object instead of a primitive. So these are object variables, but the data they store is just associated with one particular primitive type. Now, Because this is sort of a utility that Java gives us to make life a little bit easier sometimes, they also give us a little shortcut. We don't actually have to use the new constructor. This is one of the other very few classes that there's a shortcut to creating objects. We can actually do what's called auto boxing or auto unboxing, where Java automatically converts from the primitive to the wrapper class automatically. So if we had a primitive variable num storing the value of 42, we could declare an integer object variable, object int, and we could just assign it the value of num. This is a shortcut. Instead of saying new integer with the value of num, we can just automatically convert from the int to the integer. And we can actually go the other way too. If we had an integer, we can assign that value to an int. So Java allows us to go back and forth from the primitive to the class version automatically without using the new operator. The wrapper classes also give us some nice handy features like constants. For example, the integer class stores the minimum and maximum value that can be represented as an integer. Similarly with the double, and there's other constants provided in the classes. They also provide some really useful methods for dealing with strings. So each one of our wrapper classes provides a method to parse a string and convert it to a primitive. What that means is if we have a string that contains, let's say, for example, the number 123, but as a string, so this is the string 123, if what we want is the number 123, we can invoke the parseInt method. Now, parseInt is a static method, just like the methods in the math class. So we invoke it through the name of the class, capital I integer dot parseInt, and we send in the string variable, the string value rather, and what we get back is an integer. So this parseInt method takes a string and basically strips out the numeric value so that we can store it in an int. And there's a parse method in each one of these wrapper classes. So there's a double.parseDouble, where if we had a string 142.3 as a string, we could send that string in as a parameter to the parseDouble method, and we'd get back a double. So this is really, really handy when converting from user input, because oftentimes when we read something in from the user, we have it as a string, we have it as text. That will always be the case once we get to graphical user interfaces, but it's sometimes the case for text-based interfaces too. So if all we have from our user input is a string, but that string contains, for example, a number, and we want to get at that number as an actual number, like an int or a double, we can use these parse methods to do that. So these are really, really useful methods. And again, there's one parse method, parseInt, parseDouble, etc., in each one of the wrapper classes. The final thing we get from these wrapper classes is basically going the other way. So if we had a number and we wanted to convert that to a string, well, of course, we could just concatenate it with an empty string. That would be one option of how to do that. But another way is to use the toString method of the wrapper classes. This is another static method, so we again invoke it through the name of the class. And we send in, an integer or a double, and we get back a string, so the string version of that number. So these wrapper classes allow us to convert from integer to string, from string to integer, or from double to string, or string to double. So some really useful methods. And again, they might not seem quite useful just yet, but once we start working with graphical user interfaces and collection classes, you'll see just how useful these wrapper classes are. So kind of start getting used to using them now, and then you'll see how useful they can be later on.